A warm welcome. My name is Jenya Shurze. Today we are looking at one aspect of quality assurance in development, static code analysis. You'll see what it is and how you can use it in a moment. Robert Martin says in Clean Code, a handbook of agile software craftsmanship, that developers spend 10 times as much time reading code as they do writing it. It is therefore important to make sure that you write readable code, that is clean code. However, it often happens that we have to read code that was not written by us and that we still need to understand quickly. This happens, for example, when we take over the maintenance and further development of an application, or when we are new to an already running project. It often happens that we have to understand the subject matter from the code because there is no other usable documentation. The analysis of existing code can take place over a different period of time. When it comes to creating an offer, you only have short-term insight into code. While a consulting assignment or project involves longer periods of time, the objective of such an analysis can also vary. In a project, for example, it is primarily a question of understanding the content, whereas in a consulting assignment, it may be a question of making an assessment or finding weak points. The methodical procedure now consists of two steps. A structural analysis can be carried out first. To do this, we look at which components there are in the system, how they depend on each other, and how closely or loosely the components are coupled. It should also be considered whether there are cyclical dependencies. A code analysis can then be carried out. The aim was to determine whether the solid principles were adhered to and where they were violated. Is there documentation for the software? If so, does it reflect the software status, or has it not been maintained for a long time? How well does the code read? So are the names of packages, classes, methods, etc. meaningful? Or more generally, are the methods of good programming adhered to? You are familiar with static code analysis from statically typed languages such as C or Java. There, a static type check is part of the compilation process. This means that these tests are carried out before the software is built and executed, and therefore differ from unit module tests in which the code is executed. Static code analysis is a falsifying test procedure, that is, it can find a certain class of existing errors, but cannot confirm the correctness of the software. The procedure is also known as linting. Data, source code, and configurations that are already available at build time can be checked statically. The syntactic correctness can be verified, for example, whether it is valid JSON or whether a Java class contains valid Java code. A check within the application for this type of error is then no longer necessary. Dynamic data, that is data that is not yet available at build time. I'm thinking of entries that users make while using the software, must be checked dynamically, that is at program runtime. Where should this review take place? Always at the outer limits, for example, when entering in the GUI, at the component boundaries that process the data. No further checks are then carried out within the component, as checks have already been carried out at the external borders. Best practice here is to keep the checks uniform across the system. Separate the subject-oriented from the technical validations. Complex tests justify a separate component. We should avoid null pointers at all costs, as they are very difficult to find reliably using static code analysis. Optionals, preconditions, or the null object pattern can be used for this purpose. Referential integrity. Data that is used as a key, for example, relational DB with foreign key, must also be present. There are numerous tools for using static code analysis. CheckStyle is a tool to automatically check the code style of Java source code. slint is a counterpart for JavaScript TypeScript code. The rules according to which this check is carried out are configurable. Experience has shown that you should start with just a few really useful rules. Otherwise, you have more work to do to make the tool happy than it brings added value. The next tool is Spotbugs, a fork of the now defunct FindBugs project. As the name suggests, it helps to find bugs in code. These can range from code smells to significant security vulnerabilities. Here too, it is better to start with fewer rules, but then take the advice seriously. Xcop offers similar functions for C# projects. Jacoco checks the test coverage. The name stands for Java Code Coverage. Coverlet is the equivalent in the C# world. The tools help to assess how high the test coverage of a software is and where tests may still be missing. JQ Assistant and Arch Unit check the software structure, whereby the rules according to which the check is carried out can be configured. They can help to ensure that conventions are adhered to. For example, in a layered architecture, a lower layer does not access a higher layer. They can also be used to monitor dependencies within the software. Version I checks integrated libraries. It not only checks whether the version used is still up to date and supported, but also under which license the library was published. Known vulnerabilities in dependent dependencies are also pointed out. Another tool that explicitly finds vulnerabilities in source code is HP Fortify, but this requires a license. Attention should already be paid to code quality during development. Many tools can be integrated directly into the IDE or, for example, started via Maven during the build process. These can also be executed by convention before a commit. It makes sense to enforce this convention using pre-commit hooks. As a result, developers receive feedback at an early stage and can react more quickly to any problems found. In addition, all tools used for code analysis should also be executed in the automatic build. Continuous integration pipelines such as Jenkins or GitLab have an integration for the common tools. Reports and dashboards can be used to display summaries, evaluations, and trends for the results. It is important to ensure that they are executed with the same configuration as locally. Pay attention to synchronization of CI and local. As with many things, it is important to use the right dose when using tools for statistical code analysis. A lot does not help much, so it's better to use fewer tools but react to the results. Prioritization is important. Coding standards are already supported by the IDEs. As long as all developers in the project have the same settings, this is often sufficient. Spot bugs, on the other hand, provides good indications of real bugs. When evaluating errors found, trends are often more meaningful than absolute figures. Is the number of warnings and errors increasing or decreasing? How does the trend change as a result of major changes and refactorings? A healthy balance must be found in the metrics. 100% test coverage is not absolutely necessary, but 0% is a disaster. So, test limit values, error cases, and equivalence classes here. Having zero style warnings in the code is nice, but it means too much effort, and not necessarily better code. The focus should be on critical components in particular. These were some brief suggestions on reviewing existing code. Until next time.